Welcome you all. Myself Nagarajan, Assistant Professor in Department of ECE at Rohini College of Engineering and Technology. In this video, let us see the optical communication first unit, third topic, that is the basic optical laws and definitions. Let us see the basic optical laws and definitions. After completion of this video, student will be able to understand the reflection, what is reflection, and explain about the reflection, refraction and refractive index, then Snell's law, critical law. So after completion of this video, these things are students will explain: reflection, refraction, refraction index, Snell law, critical law. Total internal reflections. So let us see the basic optical laws one by one, and also we define the definition of the laws. So before studying the how light actually propagates through a fiber, laws of governing the nature of light must be studied. So these are called the laws of optics. This is also called as a ray theory. So first one is a reflections. Let us see the diagram. Here the waves is incident ray is reflect the surface, and it is reflected by the ray is called as a reflected ray. So law of reflection is a pi 1 is equal to angle of pi 2. So the law of reflection states that when a light ray is incident upon a reflective surface at some incident angle from imaginary perpendicular normal, the ray will be reflected from the surface at some angle pi 2 from normal, which is equal to the angle of incidence. So law of reflection generally we called as a angle of incidence is equal to angle of reflection. Now let us see the refraction. So incident rays is incident at a surface. Refraction occurs when light ray passes from one medium to another. The light ray changes its direction at the interface. So refraction occurs when light ray passes from one medium to another. The refraction occurs whenever density of medium is also changed. Refraction observed at air and water interface, and also air and glass interface. Let us see the refractive index. The amount of refraction or bending that occurs at the interface of two materials of different densities is usually expressed as a refractive index of two materials. Refractive index is also known as the index of refraction and denoted by n. The refractive index is expressed as the ratio of the velocity of light in free space to the velocity of light of the dielectric materials. So generally, that is the refractive index is nothing but it is the ratio of the speed of light in air to the speed of light in medium. So in refractive index we have a two medium. So refractive index for vacuum and air is a 1, and for water it is a 1.3, and glass refractive index is a 1.5. And next let us see the Snell law. So Snell law is states that high light ray react when it meets the interface of two media having different index of refraction. So this is a Snell's law. So let us consider that is a pi 1 and pi 2 be the angle of incidence and angle of refraction respectively. Then according to Snell's law, the relationship exists between the refractive index of both materials is given by n1 into sin pi 1 is equal to n2 into sin pi 2. So here that is a refracted wave will be towards the normal when n1 is less than n2, and will away from it means when n1 is greater than n2. So n1 divided by n2 is equal to sin pi 2 divided by. The equation shows that the ratio of refractive index of two mediums is inversely proportional to the refractive and incidence angles. Refractive index n1 is equal to c So next, let us see the total internal reflection. So it is considered as a TIR. In this diagram, so incident rays are meet at the surface and reflected rays are, that is the angle is considered as a pi 2. Incident rays are angle is a pi 1. When these two mediums are less dense, it is considered as a N2, and more dense means it is considered as a N2. So the total internal reflection, when the incident angle is increased beyond the critical angle, the light ray does not pass through the interface into the other medium. So it gives the effect of a mirror exists at the interface with no possibility of light escaping outside the medium. So in this condition, angle of reflection pi 2 is equal to the angle of incidence. This action is called as a total internal reflection of the beam. So TIR leads to propagation of waves within the fiber cable medium. Two conditions necessary for TIR to occur are the refractive index of first medium must be greater than the refractive index of second one. The angle of incidence must be greater than the critical angle. So let us see the review questions from the Anna University. They explain the phenomena of total internal reflection using Snell law with figures and calculation. Describe the ray theory behind the optical fiber communications by total internal reflection. State the application of Snell law and it. So with the diagram, explain total internal reflections. Explain the ray propagation and down an optical fiber cable. Also derive the expression for acceptance angle. Dear student, I hope that all of you understood about this basic optical laws. Thank you.